Whenever you're ready, Daniel.
All right. Well, I think we can continue on from the question that was just mentioned before the break. Like, well, should we trust these pre-registrations? And I have a nice example. But first, ideally, right, if we want to be able to evaluate the severity of a test, we have to have enough detail in our pre-registration. So we need to be able to see what did you actually plan, which means, for example, saying whether you'll do a one-sided test or not. The easiest way to describe everything related to your test is to pre-register the final analysis code that you plan to run on your data. Now, that's maybe something people are not accustomed to write them before they actually have the data, but you can create a very small data set that looks somewhat remotely or even closer to what you actually expect, and then write your analysis code. You have to do it anyway, and that can also be in software like SPSS, where you just click around and you save the syntax. So this is ideally the level of detail we have in our pre-registration. Now, yesterday I was browsing Twitter, and I saw this post by Don Moore, and he says, yeah, our journal club read a paper. There were 8 studies in the original paper. They tried to replicate 5 of those studies, and basically they just failed to replicate these original claims. Below is the abstract of the original paper published in PNAS. 8 pre-registered analysis, altogether a huge sample size. The 8 studies all showed support for their prediction. And then we have 5 replications, and none of them show an effect. And I think people are not sufficiently upset about something like this happening. Like, this should not happen, right? I mean, we have 8 studies showing something. It should be pretty strong support for something. We're not talking about a single study that might not replicate, but you did 8 studies. So then you wonder, how can this be? Because wasn't pre-registration sort of supposed to prevent this kind of stuff? Well, this is the pre-registration of study 1. So we can take a look at what people describe. And here they say, well, for example, in the sample size, how many and which conditions will participants be assigned to? Well, how many is not mentioned. So they don't even say how many data they'll collect. So we don't know. Maybe they kicked out some participants or collected a bit more than they wanted. What is the analysis? We will use a one-way ANOVA to compare differences across conditions. There's a little bit more, but in essence, this pre-registration is so vague that it still allows for a lot of flexibility. Yeah. Should we trust this study more because it's been pre-registered? Well, if it's this vaguely pre-registered, maybe not. In any case, there's something very weird going on where we have 8 studies that show something and then we still can't replicate it. So pre-registration is not a cure for replicability. I think it improves our ability to evaluate the studies that have been done. But I think this is a very interesting case. And it's not like people can maybe not know how to pre-register. Everybody has to learn certain things. I think that's fine. But I don't think we should feel comfortable at all if there are 8 published studies in the literature and they are pre-registered and somebody tries to replicate it and nothing works. I think that's a huge problem. Anyway, people didn't seem to be as upset about it as I was, but I think this is an interesting case that deserves a little bit more of reflection. Now, in this previous paper, these 8 studies, they all show support for the hypothesis. That in itself is extremely unlikely. Even if you have high-powered studies, showing a significant result in 8 of them is not supposed to happen. You're supposed to have sometimes non-significant results. They're called type 2 errors, even if your hypothesis is correct. If you aim for 80% power, well, they're quite likely to happen, actually, these non-significant results in a set of 8 studies. So what happens if scientists only publish significant results and they never report their non-significant claims? Well, we of course have a bit of a problem. We have the same problem as when we selectively report analysis within a study, but now we have it at the across study level. And it also reduces the severity of tests in the sense of, just as we saw before, you can end up with almost 200 tests of the ego depletion literature, but then, for as far as we know, most of them were just type 1 errors. They're all flukes. So this is a problem separate from flexibility in the data analysis, that we don't publish everything. There's a nice paper by Sterling in 1959 where he shows that about 97% of hypotheses that have been tested already show their prediction. Sam explained this. He pointed out this very funny paper that we can just predict the results without collecting data in one of his talks. All right, so this is the original table by Sterling, but I won't dwell on this. Basically, we have a lot of evidence that there is publication bias. People selectively submit things that work out, basically because they're statistically significant. So if these non-significant results are missing, then, well, in the extreme case, everything that's in the literature is a type 1 error, and everything that's unpublished is a true null, and we should reach the conclusion that there's no effect. But because we only share the significant stuff, we basically fool ourselves about the presence of an effect. But in other cases, what's also going to happen is that the effect sizes are hugely inflated. So that's another problem. And I mentioned this worst case scenario. Everything is actually a type 1 error in the literature. And I think really, based on my evaluation of the ego depletion literature, that's what happened there. So how can we prevent not knowing what other people have been doing? Again, we're trying to increase the transparency of the reporting. So there was a presentation about study registries, which are happening in clinical trials for many years. So in a study registry, people have to basically say, hey, this study exists. I am going to do a study examining the effect of this intervention on this thing. So this is just to say that the study exists. That was the original goal. Clinicaltrials.gov is a place where people can register their trial. You get this confusion between pre-registration, as we used in psychology, and registration of trials. We can do both, but the difference is pre-registration is this term that psychologists and now other fields use to say, this is my plan, how I'll test my prediction. In economics, it's called a pre-analysis plan, a PAP, PAP, they abbreviate it. They don't use the word register because they also have registries, so maybe they thought it looked too similar. So anyway, there can be some confusion, but a registry is basically where we say my study exists. There were some reasons why registries like clinical trials emerged. Interesting to think about. One is that some pharmaceutical companies hid side effects of drugs they were testing, like antidepressants. They didn't show they had harmful effects because those effects were suppressed. They weren't shared. They got sued. It cost them a lot of money. So that's a good way to change people's behavior. Sue them if they do the wrong thing and fine them. The International Committee of Medical Journal Editors, a group of editors of top journals in this field, said, hey, you know, we really think that this is important. We will only start to accept studies that appear in a registry from 2004 onward. Well, then people wanted to get into those journals, so they started to register. And there were subsequent regulations by funders. National Institute for Health, for example, really pushed these registries as well, made sure that they would happen. So in all of these cases, it's not the researchers themselves who thought, hey, let's organize ourselves. Let's fix this problem. All these three solutions are external, either journal editors, funders, or lawyers, basically forcing people to do, well, the right thing in the sense of this decade or century-old problem of publication bias needed to be addressed in some way. Now, in these registries, people need to specify their main test, but over time, they became more and more detailed. And basically, over time, they become more similar to a pre-registration. So they're started with different ideas, but they're sort of drifting towards the same thing as a pre-registration in psychology. And one interesting thing is that people now have to update these registries with the result. So we don't only know that the study exists, but if there's a null effect, people have to go back to the registry and add, this is the effect we found for our main test. That's quite interesting. Now, of course, people often didn't want to do it. Either they were too busy or maybe the results were null and they didn't want to share it. So then they forced people to do this. Again, forced them to do this. If you do not update your results, you can be fined. The FDA doesn't mess around. So you see here, if there's a violation and they don't fix the problem after 30 days, they can, I think as far as I know, they have never yet done it, but they can fine people up to $10,000 for every day that they're late. Yeah, right. Nice solutions to these problems. They don't sound attractive, but I think, personally speaking, this is what you get if you don't clean up your own mess. So study registries exist to increase the availability of study results, reduce publication bias. And you see here what the results are of having to specify just the main analysis. This is studies in research from the National Heart, Lung and Blood Institute, before and after trial registration, where people have to say, this is my main analysis. This is the main thing I'll test. So on the left, you see all these blue dots are significant results. And on the right, there are only 2 significant results, many more non-significant results. So people sort of joke, if you have to register your trial, it becomes less easy to find significant effects. Now, so we're talking about study registries. They also have other effects, such as making these studies known to other people. And as I mentioned, over time, they became more and more detailed. So they really are starting to look a lot like pre-registration. So they're not exactly the same. Toby Wells pointed out yesterday that clinical trials registrations are a little bit different. But in my experience, in many fields, the difference is becoming smaller and smaller. Because, yeah, if you register anyway, why not add more detail? And then you basically have all the benefits also of preventing flexibility in the data analysis. So in some way, when they do both of these things, study registries basically combine study registry with a pre-registration. So that's a good thing. Now, you can still register in private. If you pre-register on the OSF, you can do this in private, at least for a number of years. So if you make a pre-registration on the Open Science Framework, not everybody knows, but after 4 years, your pre-registration will become public, sort of in the fine print, because they want to prevent publication bias and not making findings known. Some other platforms, like As Predicted, don't do this. They allow you to keep your pre-registration private forever, but the OSF makes it public after 4 years. So they try to act a little bit more like a study registry as well. All right. Now, we're talking about publication bias and asking people to register their studies. That's one way to do it. But in psychology, we also introduced registered reports, which are an even more severe form of preventing publication bias. And I think they're an extremely interesting solution to a couple of problems. They roll a number of problems or solutions to problems into one. So they're a very attractive way of working, I would say. So in a registered report, you basically send in your study ID, and then you get feedback from peers. You get basically you submit your introduction and your analysis plan and your methods, but you don't have the data yet. You say, this is how I plan to collect the data, and this is why that's interesting to do, and this is how I'll analyze it. And this package gets sent for peer review. Peer reviewers are going to take a look, maybe give you some suggestions on how to improve things at a moment where you can actually still incorporate those improvements because you didn't collect the data yet, which is lovely, of course. When I review something myself, I much prefer to review a registered report because then I say, this is not a very good idea, but you can still fix it, than registering a normal paper where I have to say, this was not a very good idea, but now you've collected all the data and there's nothing you can do about it. It's slightly less fun to have to do. All right, and then if the peer reviewers say this is a good study, it will receive in principle acceptance. That means that before you do all the hard work of data collection, you know that the paper will appear in print, that it is already accepted for publication as long as you follow the plan. All right, so that's basically what registered reports are supposed to do. So these are the 4 steps. I already mentioned them, just to briefly revisit. You develop the study rationale, the design, the analysis plan. And then you can send this off for peer review, which is called stage 1 peer review. Of course, they can still be rejected. If they don't like your idea, you might not make it into their journal. They will still happen, but at least you know before data collection. Often they will ask you to change something about the plan, and then you receive this in principle acceptance. Now, you can still, make some changes even after in principle acceptance, but then you have to go back and discuss it with the original editors. You collect the data, you write everything up, and then you send it back. And then there's stage 2 peer review, where they basically check, did you follow all the things you said in advance? Do the conclusions you draw follow from the data that you have? And then, it can't be rejected because there's a null result. I mean, that's taken into account at the beginning. So, of course, this practice has benefits. Because you get peer review before you collect the data, right? That's actually pretty nice. But the other benefit is, of course, that we prevent publication bias. It also has some downsides because you have to wait for the peer reviews, and that can take some time. So that can be a bit annoying. You have to submit it. They have to find reviewers, and that can just take sometimes a bit longer than you want. So that requires some careful planning. People have also worked on some solutions. I'll come back to it in a second. Now, these registered reports are a relatively new invention, and they come from the field of psychology. They've been proposed in the past, also in psychology. Actually, one of the earliest versions of this is parapsychology, where people, of course, had a lot of claims that nobody believed. They're like, what can we do to make things more credible? The first were published in 2014, actually in a special issue that Brian Nosek and I edited of replication studies. Chris Chambers has worked tirelessly since 2013 when he came up with the idea to spread this to as many journals as possible. And over 300 journals now do this. This is from a review paper, basically showing the development over time. And this is something that makes me a little bit positive, right? So in a decade, only a decade, we have this development that these registered reports exists. They've become accepted. They're not criticized. There's actually some criticism of practice such as pre-registration, but there hasn't been a lot of criticism of registered reports, because they're just basically a pretty good idea. So maybe somebody will publish some criticism on it, but recently did a review, and there's just no criticism of this, because I think people are just like, look, if this is what you want to do, that is a pretty nice way to publish a paper. It also has some positive effects. So remember this Sterling finding of publication bias, that 97% of findings are significant. We showed a couple of years ago that for registered reports, which is the bar on the right, only 44% of findings are statistically significant. So they are a way to get null results in the published literature, which is also nice, something we need. All right, so that's a useful publication format. Registered reports, they can help to make the scientific literature a little bit more realistic, because all these papers with only significant results are just not realistic. That's just not what happens in real science. Null results are also surprisingly common. We don't know exactly how common, of course. We don't have good numbers on it, but more common than you think if you browse the scientific literature. So if you fail to find effects, don't worry. You're a completely competent scientist. It's not you. This is completely normal. It's just part of the scientific process we've hidden for a very long time. So maybe it feels like you're not doing a good job, but you're just doing a good job as everybody else. The quality of these registered reports, maybe because there's been peer review beforehand, is, if anything, a little bit better than for normal papers. So this is a recent study by Soderbergh and colleagues. Of course, the methodological rigor is judged to be higher, a lot of focus on the methods, the quality of the methods, the informativeness of the study. And this is because peer reviewers will say, well, if there is a null result, which can happen, of course, in a registered report, we want it to be an informative null result. That means that journals like Nature Human Behavior require people to also plan statistical tests for the absence of an effect, either by using Bayes factors or using equivalence tests. And this is something many people still don't do, even though they should. But in this registered report approach, people require you to think about it in advance. Otherwise, they won't accept the registered report for publication. The importance of the research isn't affected negatively by it. Some people say, well, it will lead to boring research. Doesn't really seem to be the case. So we get the same research, but just of higher quality. That's how it looks like. So these registered reports combine a couple of things, pre-registration, and so we don't have flexibility, and a journal format that prevents publication bias. And the pre-registration you do by yourself, and we saw at the beginning of this second part, some people just do a pretty bad job at this pre-registration, but in a registered report, this pre-registration would be peer-reviewed, and you couldn't get away with pretty low-quality pre-registration because it wouldn't be accepted. So that's a pretty big benefit of registered reports. And some registered reports even make the proposal public if the proposal is rejected. So there's really a lot of transparency about what people do, basically. All right, so just to round this up, there are a couple of benefits. I think especially if you're an early career researcher, supervisors are sometimes very busy. They will give you feedback, but I don't think it hurts to also get feedback on your planned study from 2 other experts in your field. So I think that's pretty nice. And you get this feedback at a time where you can still improve things, which is really nice, because otherwise you're stuck with data that people criticize. You can't fix it. And especially if the data is very cumbersome, takes a lot of effort to do, or there's a high risk of no result, and you are worried about even being able to publish it given publication bias if there's no result, well, you know that the study will be accepted before you collect the data. So that's also very valuable. Now, I already said it requires some planning because you have to wait for the peer review process. And here, there's also a very interesting novel development, which is peer community in registered reports, a way to get registered report review outside of the journal system. Very exciting kind of development, if you ask me, something that might be the future of the way scientists should publish. And the nice thing here is that you can schedule the review process. So you can say, hey, dear editor, 6 weeks from now, I'm going to send you my registered report. It's going to be on this and this topic, so you know which kind of experts to invite. Can you already find these people and tell them to mark their calendar 6 weeks from now, block an afternoon to review my registered report? Then as an editor, we do this. We get the review. These people have already said, yeah, I can do it in these 2 weeks. So you get the reviews, if everything goes well, rapidly. It's a lovely solution to this time issue, which was the main problem with registered reports. It nicely addresses that part as well. Pretty exciting developments, I would say. All right, then the last part, which is about deviating from your pre-registration. That was supposed to be the main part of the second part, but I think we don't need to talk about it too long. We'll see. So first of all, it's important to point out that some people, especially if they have experience with pre-registration, so they're a bit experienced, and they have some experience with their research line, are able to make a pre-registration and perfectly stick with it. So it's possible to do this. However, deviations are also quite common, very common, I would say, and especially if you have less experience in pre-registration or less experience in the study you're doing, then it's even more common to see deviations. Now, deviations are not problematic per se. The whole thing about pre-registration is that we have transparency about your analysis plan, what you predicted in advance, and what you ended up doing, so that we can evaluate the impact of any deviations on the severity of your test. And I don't have to explain that this severity idea is at the core of doing these pre-registrations. So as I mentioned in the beginning, if your argument for a deviation is, well, if I move from a 2-sided test to a 1-sided test, my finding is significant, so that's why I'm deviating, I can evaluate this and I'll be like, well, that's not a very good reason, right? So that's not a good justification for a deviation, but there can be very good justifications for a deviation. And importantly, sometimes they have no real impact on the severity of the test. And in those cases, a deviation doesn't really impact your pre-registration. It doesn't impact the severity of the test. So let's take a look at some of those examples. So what are common reasons in the scientific literature? Because there's meta-scientific work on this, but also from my experience doing them myself or editing these kind of journals or papers. What are common reasons to deviate? Well, first, unforeseen events. Something happens. COVID was a pretty big one, right? All of a sudden, you couldn't go into the lab. All right, so you have to deviate from your pre-registration. A second one is errors. Now, Dorothy Bishop has some lovely papers on how open science practices mean that it will become clear when you've made a mistake. And that kind of sucks, because now you have to show everybody that you made a mistake. You have to address it, but that's real life. That's what research looks like. We all make mistakes. We were just able to hide them. Third category is missing information. That's a pretty big one, especially if people do pre-registrations like the one I showed before, where there's just not a lot of information in there to begin with. And then there are two more specific ones. One is where you violate some assumptions you had, but you didn't test them. Something happens, something unpredicted. I'll explain that in a bit. And the second is the same, but here we can actually test whether an assumption you had is violated. We'll come back to these two. They're a bit more specific. All right. Now, when you deviate from a pre-registration, which is perfectly fine, what you're supposed to do is weigh two components. The one is the severity of the test. That's what we've been talking about. But why would we deviate? Why would we sacrifice a severe test? Because we actually gain a more valid test. If you pre-registered a dumb analysis, which happens, even if you thought about it, you came up with something, it's just not a good idea, you should do the better analysis. That's the more valid analysis, and then your claim has higher validity. And that is what we want, of course. It doesn't matter if you had a severely tested, invalid claim. So sometimes you have to deviate from your pre-registration because you gain validity, you reduce severity. In the case of the switch to a one-sided test, because that makes it significant, there is actually no gain. There is no increase in validity of the test. So here, an evaluation of these two things would be like, okay, this is now a less severe test, but we didn't gain anything in validity. So this is just a weird thing to do. But often, of course, if we do it well, the deviation will be to increase the validity of our results. So you sort of have this 2x2 outcome that you can have, where the deviation actually lowers the validity and the severity. This is what happens with p-hacking. There's no good reason to do it. We don't get a more valid test, but we get a less severe test because you've deviated. And ideally, we are in the situation where we get higher validity and even maybe higher severity. Now, that can happen. I'll explain how, but not always so easy. But it can happen that you actually have a more severe test. This is especially true if your original plan for the measure was invalid. And then if you test it, it's also not a severe test in the sense of, even if you're right about your prediction, a bad measure can never show that you're right. So if you use a better measure or you compute the measure so that it's more valid and reliable, it's also a better test of your real prediction. All right. So have you ever needed to deviate from a pre-registration? And if you have, maybe, well, I don't know, the chat is not open, I guess, but maybe you can do it as a question or something. You can add it somewhere else, maybe in the Q&A or something like this. I don't know. Or you can just say so. It's also fine. Does anybody have a deviation so that you can share?
space.
It's fine.
Yes, so you probably something to worry about it.
We work on hypothesis.
Again,
We work on hypothesis because it was stupid.
Drops and it was too big.
Stupid.
It's too big. I put it too big. So I
There's
was going to say that's quite a.
not in the paper.
There's a footnote. Oh well, it's. Any advance on hypothesis being stupid? Oh, Charlotte's.
So I'm just about to perform a major deviation from a pre-registration in study. And this is because it's my first fMRI study. So I'm an experimental psychologist. I didn't really know what I was doing. And we used a visual search task with a scanner to look at attentional bias towards alcohol stimuli or neutral stimuli. But those stimuli are within the same array, and they were randomised within the trials. So in our pre-registration, our analysis plan was to look at the brain responses towards these different stimuli, but we actually just cannot perform that analysis test because the brain was seeing everything and it's responding to everything, and everything is in 1 year's lighting up. So we've had to perform a principal components analysis and a brand new analysis test to pull out discriminative brain regions because otherwise visual cortex is just going wild. And I'm somehow going to have to explain that it was just because I was inexperienced and stupid and picked the journal still likes the paper.
Stupidity in real.
Well,
It's a good thing. It's a good thing. There's a paper on the importance of stupidity in science. I mean, I've got mine to throw in my hands in there. I do quite a few meta-analyses, and those are very hard to predict how they're going to go. And there's so many times where either we've realised once we have had a look at the data that we just can't run certain analyses, and we've also found data which has made us motivated to run different analyses or supplementary analyses as well. So that's my deviation. So I'm also relatively as well. It's probably loaded work. Any others from the floor, and then we'll go back to. Yeah, I think that's enough for now.
there was one person in the back, maybe. Yeah.
That's where very bad. Right. That's it.
I've got an entry artistic understanding. So they clicked to withdraw, but then that that was an accident. So I had to replace them with somebody else. So I've got one extra participant. I've got more stupid examples. It's not a way to do that.
Yeah, but that's nice. And I think so. First of all, it's nice that people share mistakes they've made. And again, I think I highly recommend Dorothy's paper on this. It's just a consequence of doing open science. We'll see that we'll see people's mistakes. But maybe, yeah, if you go to the slides back, I can very briefly just mention some of these sources of deviations. And the sample size issue is the biggest cause of deviations, actually. All right. So first, of course, is unforeseen circumstances. Weird things happen, like an explosion in the lab or something else. The thing with real unforeseen circumstances is that they are outside of your control. So whatever happens after this, it's not something you can opportunistically manipulate. So often the consequences of some unforeseen circumstances are actually not that big. You can just change, there's not a lot of options of how to deal with this unforeseen circumstance most of the time. So you didn't have a lot of flexibility to begin with. So real unforeseen circumstances are really not that bad. One part of unforeseen circumstances is not ending up with exactly the sample size you pre-registered. And here the unforeseen circumstances, a participant, I had to throw out one participant because, I don't know, something happened. Or maybe more people did this study than I thought were doing it. Some people finish the study in the last day. So if you take a look at the literature, there's often some numbers like, yeah, the percentage of people who deviate from a pre-registration is very high. But then if you take a look at, okay, but what happens? Yeah, they have 2 more participants. Instead of 304, they have 306. And you're like, oh, well, okay. That's not really such a bad thing. It's a deviation, sure. The solution is actually most often to not specify the exact sample size. I know that's weird, but you can't really precisely predict the exact sample size in some situations. If you can, do it, by all means. So you can actually pre-register analysis such as sequential analysis, which are much more flexible ways of collecting data. You can then flexibly spend your alpha level over looks at the data. And if you oversample, I mean, I wish I could spend more time explaining this, but I'm just pointing you to the fact that this exists. If you sample more than you predicted, with these kind of alpha spending approaches, you can compute the alpha level to take a look at every look at the data and control these kind of issues. I just want to mention it is underused a lot, but it's one way to have more flexibility and still pre-register. But the other thing, and maybe this is also controversial, is not to pre-register the final sample size, because the exact number is difficult to pinpoint. But you can pre-register the stopping rule. We'll stop collecting data at Friday, 5 o'clock in the afternoon, or whatever kind of rule. And then you have your data cleaning script, ideally pre-registered, and you specify that. And then, of course, that leads to a certain final sample size, which is hopefully close to what you need to have high power, but it might be 1, 2, 3 off, and that is not a big deal. Another way to deal with this, by the way, is to show that even with 1 extra person or 1 person less, there's no effect of the missing person or the extra person on the results. So if this deviation doesn't impact in any way the final conclusion, it also doesn't impact the severity of your test. So if you have 1 participant too much, you can just analyze it with removing any of them and say, look, it doesn't matter. If you have 1 participant too little, you can say, look, it doesn't matter what this participant would answer. Nothing would change in the results. That's also a way to show that the severity of the test is not impacted, even though it doesn't perfectly adhere to the pre-registration. And in many cases, if you end up with a larger sample size, it's even a more severe test, especially if you can rule out any opportunistic extra sampling. You just ended up with more people, but out of your control. Well, then it's a more severe test because you have higher power. So you'll find it if it's there, with a higher probability. All right, the second is mistakes. They also happen. People have already mentioned it. This is an example again from Twitter. Somebody says, we likely pre-registered a wrong hypothesis. We said lower, but we should have said higher. So they really pre-registered in the exact opposite direction. And then they say, well, but theoretically, the other one doesn't even make any sense. Yeah, okay. So I think if you can really argue this and your peers agree, they say, look, this is clearly a typo. This is just an error. Yeah, you made a mistake. You correct it. Nobody thinks you're opportunistically doing anything, right? So these deviations are also fine. If you would stick to the plan, of course, you're doing a useless test, an invalid test of a prediction. So you have to deviate, right? And if the way to fix the error is just there's only one way to do it, you're also fine. Often there's some missing information. So people don't follow checklists for pre-registration, such as one by Wicherts and colleagues, published in Frontiers in Psychology in 2016. Can highly recommend that. It's a good checklist to not miss things that you should include in your pre-registration. So, for example, they didn't specify the directionality of the test, even though Bacon in 1966 said this is why we need those registries. But they forget to say, is it a directional test or not? Well, maybe it doesn't matter for your analysis. Fine. Then you can just fix it afterwards. It doesn't matter. And if it does matter, yeah, then you have reduced the severity of your test. If you say, well, we really wanted to do a one-sided test, we forgot to say it. It's only significant if we do a one-sided test. Yeah, sorry. But then it just comes at a cost of the severity of the test. People take a look and they will be like, this is not so good. So too bad, but then, yeah, you don't get the benefit of the pre-registration anymore. Then these last two categories, violating untested assumptions. So often we think something will happen about our data, the way that we collect it. For example, we think that people will answer seriously. So we don't say, okay, but if they wander in drunk and they click around, I will kick them out. I mean, we don't specify that because we don't expect people to do this. Or in our survey, we expect people to be honest and only enter the survey once. We don't think about it sometimes, but people actually sometimes do it multiple times, especially if they're paid, and then you have to filter them out. So these are violations, untested violations of assumptions, untested in the sense of sometimes we just have to make a sort of best guess. Like, how should we deal with this? Is this really a violation? Was this person really drunk? I don't know. How can we say? So sometimes we have assumptions about what will happen during data collection. People do something weird. Yeah, and then we have to ad hoc make a decision how to deal with it. It's also a deviation. And very often these will impact the severity of tests. That's just how it is. You have to make a decision after the fact. Could be opportunistic. We don't know. The best way to prevent this is to build expertise in the kind of data you collect, to build a sort of, a data exclusion procedure that is very valid and catches all of the things. It will also be updated over time. We'll live and learn, right? So over time, we'll get better at this, but this is a big one, especially early on in pre-registrations, and that's just what it is. I mean, you can't really fix it. You can learn, you can take a look at other pre-registrations of high quality. What do they do? Should I also build in kind of decision rules like this? What kind of data can I expect? And otherwise, really, pilot testing is a good case. You'll still have this weird one drunk participant every 10 studies. That's unexpected, but you will catch some of these other things. And finally, sometimes we violate some sort of assumption. So we, for example, think that our measure is reliable with the items that we saw people use in other data sets. And then we take a look at our data and it's not a reliable measure. And we need to kick out one item and that will make the measure more reliable. Or maybe we thought data would be normally distributed, but it's not normally distributed. And we have to do a different test. And we didn't plan this, we didn't expect it. But we can test, we can see here that the test is unreliable. The benefit of being able to test things is that the deviation has to happen. If your data is not normally distributed, you have to use different statistical tests. And therefore, it's less opportunistic. So there's a better explanation or justification for why you're deviating from your pre-registration. So if you falsify some assumption, you have to deviate. So you don't need to justify it anymore. It's clear why it happens. And then the impact on the severity is sometimes less severe, right? Because you didn't have a lot of opportunistic possibilities to mess around with your data. All right. And again, the more experience you have, the easier it is to fix these kind of issues. And then the last recommendation is just if you have these cases, try to transparently report all deviations. How to do this best is a current topic of research. There are some people who take their pre-registration and copy the text that they're writing in the article side by side. That's a kind of nice way to do it. There are also people who take the pre-registration and then say, okay, we deviated for this reason or this reason or this reason. There are some examples and papers on how to do this, sort of tables where you list all of the predictions in your pre-registration and you say, how did we test it? What happened? And if we deviated, why did we do it? And for this part, again, what I would highlight, other people have pointed out other things to mention there, but what I would highlight is, does it negatively impact the severity of the test? That doesn't always have to happen, but sometimes it will. Then just acknowledge it. And does it increase the validity of the test? Because it should have some benefit. There should be a good reason to deviate. You should do a more valid test. So explain those two things. That would be my recommendation. All right, so this is sort of from a paper I have on this on when and how to deviate from pre-registrations. This is basically the 5 most common situations and what to think about. It's pretty simple, but I think having a bit of a formal approach to this is useful as well. All right, some of the stuff I described is in these papers. I've written 4 papers on pre-registration and registered reports in my career. I decided I published the last ones this year. I think this topic is basically done as far as I'm concerned. I think we've discussed this for a decade and figured out what we need to figure out, or if not, other people can take it forward from here. All right, thanks.
Okay, so we're at 11, and then we were going to go to the panel. So I guess we could take a few questions, a quick break, and then we'll go to the panel, as that sounds. That's good for you, Charlotte. So, yeah, I'll put him on the screen now.
Yeah, sorry, I talked a bit too long, but
No,
we can take 1 or 2. And also, people with questions can always email or something if you want to discuss this in more detail.
Yeah, so whilst I examine the Q&A on the online, does anybody have any questions for to ask Daniel? Yeah.
Very informative talk. In terms of pre-registration as well as registered reports, would you normally do that before you can or sorry if it's already a question.
Sorry, it's for some reason the delay or something in the audio makes it difficult to hear. Sam, maybe you can repeat it if you're closer.
Yeah, the timing of the registered report or pre-registration, how does that tie in with applying for ethics? What would be your suggestion? Yeah.
Good point. Yeah. And if you're closer to the mic there in the front, it works better, Sam. I don't know why, but there's something about audio delay or something. But the timing can be a bit of an issue. So because if people say, hey, you need to change something to your study design, you have to add some questions or remove them. You also need to go back to research ethics and update it. It depends a bit on the procedure. So how specific did you need to be in the ethical review board procedure? And what were the changes that people require? But it's true that sometimes you can go back, need to go back if there's an addition. It's another problem. It's a good one because I don't think that has been addressed yet. At our university, what we do, I happen to be the chair of the ethics review board of our university. And yeah, people can always just email us directly mentioning what there's as a change. And then we very quickly reply, especially if it doesn't really matter. And that's basically my experience always. Any changes that happen due to peer reviewing a pre-registration or a register report have never really changed the decision of the ethical review board about the study. So that happens quickly at our place, but it might not be so quick in other places, and then it can cause an extra delay. That's a completely fair point.
Thank you, Daniel. We'll take one online. So if you want to run a pilot trial, do you pre-register or pre or post-piloting?
Yeah, so I think it's very normal to do some pilot work in advance to explore your data, get a better understanding of it. We also have a paper which is called Why Hypothesis Testers Should Test Less Hypotheses. And people think they can immediately jump to this pre-registered test. But you actually do need to do some piloting. And after that piloting, that's where I would pre-register. If you want to be very transparent about the process leading up to the test, I would recommend more sort of an open lab notebook where you say, we did this pilot study, we learned this and this, we did this pilot study that led to the conclusion that this and this, and then at this moment we pre-registered. That's what I think is the best workflow.
I'll just check the, okay, the flurry of comments now. You may be able to see them, Daniel.
We can always bring them into the
Yeah,
panel
good.
as well as before.
Yeah, should we do that? Should we? Yeah, we'll have a quick 5-minute break. So we'll regroup at 5 past. So that's less than 5 minutes because we've got another speaker who needs to leave earlier than we'd like because he's a very busy guy. So we will regroup at 5 past and then we'll push any of the questions over to that. So See you in a sec, Daniel.